All right. Thanks, everyone. My name is Dan. I am here to tell you about the pinkest pink that I have ever seen on a screen. Imposter syndrome time. I'm a front-end developer, not a Rails developer. My Rails experience is in 2011. There was like a DHH blog, how to make a blog post. That was my tutorial, and then I went back to JavaScript. But yeah, I'm here to tell you about some new colors I discovered on the web. I learned about a cool thing. I'm not an expert in color. I'm a front-end developer for a long time, but this is me like learning just enough to try to be able to explain it to someone else. So I am doing my best to like simplify some of these ideas and like smush some things together in a way that may not be like 100% scientifically accurate, but I think it helps make the point a little better. So a big thank you to my colleague, Chris Cook. So I work at Canva. I didn't learn any of this as part of my job at Canva. I just like happened to work with a bunch of smarter people than me. And so when I learned about some stuff, I went to Chris and he told me how to fix all of my incorrectness, which is really cool. Chris works on the photo editing team. So they faithfully render colors when you've uploaded something into a Canva design. So yeah, and like shout out to Chris, but like some of the most thoughtful feedback I've ever gotten, like really engaged with it, which was very nice. Okay, so our story today starts with a man named Anish Kapoor. He is an artist, mostly of sculpture, but a few different things. And if you haven't heard of Anish, you might have heard of a product called Vanta Black. It was a pigment, like a chemical pigment. It absorbs 99.8% of light, the blackest black that was ever created. So Anish went to the chemical company and bought the rights, the patent to the pigment, making him, by some definitions, the owner of the color black. The artistic community wasn't too hot on this idea. Stuart Semple liked it so little, he created his own pigment. It's called the Pinkest Pink. And when you buy it, you have to promise that you are not Anish Kapoor, and that you are not going to give it to Anish Kapoor, and that it's not going to make his way to that man at all. Of course it has. There's a great photo of Anish Kapoor like flipping the bird with his fingers covered in pink, but I just love the drama. But so I bought some of this stuff. The Pinkest Pink, it's very cool. And I think the screen doesn't do it justice. It's so aggressively pink, and the colors we look at on most of our screens don't fully capture that, I don't think. But like screens are really good now. Like I've got a nice OLED at home. My phone screen is beautiful. But to like truly experience this color of pink, I think you would have to be quite careful about the layers of technology that went into like storing that image and then displaying it back to you. Like we're at the edge of color right now. And like in particular, if I wanted to use the Pinkest Pink's color described as like, you might be familiar with like a hex code to represent the RGB values. I don't think I could do it. I think this pink is beyond that. Like technology is always chasing reality. So how closely can we reflect reality with the tools we have? We've made the screens much better, but actually also the way we describe the color itself needs to get better. So the color space, we'll discuss this keyword a little bit more in a minute. Like that's the one that we use most of the time online. That's the one that you will probably mostly only have experienced, and it just doesn't have that capability. So a bit of a caveat. What I'm talking about today, I would say, is mostly how some of these color science things have been made available in web development. Some of these technologies are like quite old, so like broadcast TV, HD TV, like video encoding. This has been a very long conversation of like, how do we get HDR? How do we get all the bright colors? And so this is like, we've brought this to CSS now. So we as developers must be able to tell the computer which color from a now wider gamut of colors than we used to have. So this triangle, you might have seen something similar, the S standard red, green, blue color space. So this is a way to describe a certain set of colors. The bigger triangle behind that is an approximation of every color the human eye can perceive. And so sRGB not only is your screen, like your screen really can only show you about 30 to 35% of what your eyes are capable of. And it's getting better, but this is like the reference standard, and so this is what's used, and so we haven't really changed it. Fun fact: the bigger triangle, the limits of the human eye, is from like 1931. A lot of this color science goes back to the 1800s. You see a bigger triangle? Oh my God, it's so bad. Okay, so I was worried about this. Doing a talk about color on like a projection screen that.
I like that because I could see the other colors on the screen. I'm like,
okay, right. Well, so there's kind of a rainbow. There's a lot of greens up at the top. Oh boy, this interesting. We'll see how we go. We'll see how we go. You'll just have to use your imagination. Yeah. So the CIE, you might see, if you ever look this up, you might see CIE referenced in places. And so that is like what I'm calling the real Illuminati, the International Commission on Illumination. But yeah, some of the color science is like from the 1800s. It's fascinating. So you might be familiar with these already. These are color models. So RGB like is a way of representing a color by mixing together reds, greens, and blues. Or CMYK is like pulling colors away until what you're left with is that. Those are all, okay, you can see that. Okay, so CMYK actually covers even less of the perceivable eye than what RGB does. And so what we are trying to figure out is like, how do we get bigger? How can we describe even more color? Another way that's quite common and in use already, hue, saturation, and lightness. So if you've seen this in CSS, the hue is color, just like the purest form, the purest version of that color as it goes around a color wheel. The saturation is how much oomph, how much of the color is in the color. And then the lightness is how much white or black is mixed into it. And then you can add opacity as well. But we can do this already. This has been a thing in CSS for many, many years. You specify a hue, saturation, lightness value, and it gives you a color. This is actually quite good. This is already very useful in gradients. So when you are transitioning from one RGB color to another, the only levers you have to like smoothly transition, it doesn't actually match what the human eye thinks would be the right natural stream from one color to another. And when you use an HSL value, we should be able to say, I want exactly the same saturation and lightness, but I want a different color. And like that gradient ends up being much smoother, which is just more beautiful. That's nice. But HSL, as we have it, is not immune from problems. So the goal is that I can change the color while keeping the saturation the same. But what ends up happening with that is some colors, this is where we start getting into the eyeball science, and I just get a little bit lost. Different hues, our eyes can perceive more or less amounts of different hues. So I'm going to go back very briefly to, you can't see this one. So this one, there's a lot more green in this triangle, and it's even more pronounced than the others. Like, I don't know, evolutionarily, we lived in the jungle, you needed to see a lot of different more shades of green. And so our eyes are really good at that. And so what happens is that the way that HSL in the browser is built, it treats each hue with the same brightness. And what that means is that you try to like just transition the hue while keeping the saturation the same, but what the human eye perceives from that is much brighter, and I can't actually read that, and that's not accessible. What we want to be able to do is like make the smooth transition in like the perceived brightness we want to be the same. So we'll come back to some of this other stuff in a minute, but I think you can see that like, yeah, there's just different amounts for different hues. So this is where what we call P3 comes in. So this is like the core technology, like the main thing that we have access to now, is a different color profile from sRGB, standard RGB, or DCI P3, as it's also known. It's just a way of describing a different set of colors. So P3 only looks a little bit bigger on this. Can you see this? Yes, a little bit bigger on this triangle, but that ends up being like almost 50% more shades, which is quite a lot. And then, as I was saying, this has been in for a long time. Adobe's been in this space for a very long time, and there are already like color spaces that go further toward the human eye, and that's again in like the video encoding. So I'm sure CSS will get some of that eventually. But how do we use it? CSS color module level 4 is now fully released, and so you can use what we call a color function, where you specify the color profile, so in this case P3, and then a red, green, blue value. So from 0 to 1, like a percentage or floating number. And so to get the maximum green, you would say display P3, 0 red, all the green, a little bit of and no blue. Now, sorry.
Are those values going back to the triangle, are they almost like numbers along the edge of each bit of the triangle?
Yeah. So if you imagine they all like sort of have a middle point where the white is, the like as you add green, you get further toward this point, and as you add red, you get further toward this point. And like so maximum, so full green is the tippy top point of this triangle up here. But again, my colleague Chris Cook would want to say this does not fully mathematically, scientifically represent the idea, but yes. Where's the black? I don't know. And I think that's maybe like a different, whereas the black is actually, it's down below.
Yeah.
So, yeah. So this is where we start to get to Pinkest Pink. So we have like, this is in Safari, the color picker there. You can select P3 colors and you can see this white line that represents the limits of the sRGB space. And we've gone where no browser has gone before. We're getting towards pink, which is quite cool. But so one challenge that we have with this syntax is in addition to, so this is still like RGB in a way, like encoding a color as a mixture of red, green, and blue, has some of the same gradient limitations as before. But the other thing that kind of gets a little bit weird is that we are used to a hex code for a color describing the RGB color space. Now, the same red can mean two different things. So because all that this value says is maximum red can now be two different things. And so it's just a little bit weird to like, for that to be an outcome. And so what we really want is P3 colors, but described as with hue, saturation, lightness. So we have the full control. This is where it gets weird. This is where I got lost in the research. There's so much color science. There is a lot of math. I am a mortal and I just wanted a bright color pink in the browser. And like genuinely, I think one of the things I struggle with is like, I don't know, I think of myself as a reasonably good developer. I wish it was easier to understand this. There's so much I had to like, wait, but what does this mean? What is a profile versus a model? And like, I kind of wish there was a little bit more streamlined. And so what I am actually doing here is I'm going to fast forward and say the magical word to remember is OKLCH. So this is a new color profile, or a new color space, sorry. That's really designed to be very intuitive for the human eye. So it solves those lightness and saturation issues, but then still gives us the HSL. Fun fact, it was proposed by Bjorn Ottosson from Sweden, and he called it OKLCH because it's a genuinely because it's an okay, it's like a pretty good, it's an all right representation of LCH. And that's just stuck and that's in the browser forever now. It's so in the browser forever. So I was describing before that like the screens got better, but then like our description of the colors, like we ran up against an edge. This basically system of math that lets us describe a color actually goes beyond what the human eye can see. So theoretically, this is the last time you'll have to learn how to describe a color, and we'll be good until we're in the infrared. This is the dangerous bit where I tell you to, on your phones, go to oklch.com to actually see this. So this is in all this was originally released on an iPhone in like 2016. And since then, I think most phones released these days, like all have support for P3 color. So we can reference these colors in CSS now. Similar to the color function, we have an OKLCH function where you pass in LCH is it's a rebrand of HSL. Lightness is the white to black. Chroma is the saturation, and then hue is the same as it was before. So you're probably looking on your phones. Oh my God, this is even worse. Okay, so the top example here just shows that like every color that's in sRGB that you can describe with a hex code, you can also describe with a P3 color. It like looks a little bit funny, but it's just a different way of learning about a thing. But we can do all of our colors in OKLCH. But then down below, there's an example where there's a P3 pink. The closest fallback that we can have for that in RGB is this color. And this is just like a thing that the website tool provides. But it's also just kind of hilarious because the crunching that it took to display on this screen here, this is definitely not, and like even people on Zoom, this is definitely not the P3 color. You really need to like go to it on your phones to really experience it. And this is available everywhere. it's been available everywhere since May 2023. This is like a really huge web standards win. So between Bjorn's blog post where he described the idea of OKLCH to being in all browsers is 2 years, which is quite neat that everyone's just like, oh yeah, that makes a lot of sense. That works. Let's go with it.
LCH. Okay.
That's a great question. Sorry, the question was, is there a difference between, or what's the difference between LCH and OKLCH? Because yes, I've used the OKLCH function here, but there is just one without the OK, just called LCH. I'm not going to pretend to have a complete answer for you, but my understanding is that some of the the way the eye perceives the different colors has been tweaked. And so some of the problems, similar problems with like lightness and brightness, OKLCH solves for browsers and for displays in a way that I don't have a perfect answer. But yeah, it's available everywhere. Just like a nice win for the web standards world. So what's still to come in CSS module level 5, I have no idea when that's going to land. But native color modifications. So in your CSS, just being able to describe a color as like this other CSS custom property variable, but 10% lighter. Or this hue and saturation from this custom property, but set to or the saturation and lightness from this custom property, but set to this hue. And so it makes it a lot like really great for design systems where you want like different gradations of a color, or like that you definitely want consistent brightness as part of your brand. And then, yeah, it just gives you more control in your CSS. There's a question in the Zoom chat. What tooling is there available to handle fallbacks for OKLCH? So like, this is what I would lead with first, is that it is mostly available anywhere, everywhere. And if not, the browser does its best. The screen does its best. You can specify, and that is what this OKLCH website is quite good at, is like, okay, this is the color you actually want. Here's the hex code, or here's the sRGB one that's like the closest. But yeah, and that's if you want to be like really specific about the fallback. But I think in some cases you probably could just like give it a shot, let it.
So when it says fallback in RGB, it's RGB fallback.
Yes. Yeah. Yeah. And that's it. Thank you very much. Yeah, a question in the back.
Like some of the devices not provide the OKLCH color, or is it for the new device only?
No, so this is where like all modern browsers, so all the evergreen browsers, the auto update browsers should have had this for over a year now. And like I actually found it kind of hard to tell like the exact which screens have support for it, but like the way I was reading between the lines, it seems like it's like common enough that like you can probably rely on it. Like do your own research, but yeah.
I think the curious thing that ties this talk together with the next full talk is that women have a very different spectrum of color perception. Men do quite often. Some women have color senses that men don't have.
Yes, and men are also like colorblind a lot more often, right?
So there's actually like there's a gendered component to this that might maybe one of the reasons why we.
Bro, that's where the screen's not showing the color picture.
I mean. Dominated by men. So I just find that fascinating.
Yeah.
My question, so Kapoor has locked down for Enter Black.
Yes.
Is there anything that's pretty close? Like I've got some very shiny windows. You may not have found anything in your research, but is there anything actually accessible besides?
Oh, that is a good question. Sorry, the question for the Zoom was, are there pigments that are pretty close to Vanta Black? I don't know. I'm sorry.
I think something did come out that was ever so slightly blacker than Vanta Black.
Just show them up. Yeah. Oh, wait, sorry, one sec. Did I bring the pink? I'm sorry, I didn't. I bought it as a gift for someone, and so they have it. But yeah, I also I'm not gonna lie, I also don't know what the like P3 color representation is of the pink pigment. I don't know. It was a physical product. They didn't tell us what the color is, but drew a line between them.
You said your front end. there.
Yes.
Do you use?
Do I use P3 colors? Okay, LCH. So working at Canva, there are many layers. All the colors are locked down. There are like variables, and if you do not use like the blessed colors, then you like out on your ass. So I think if I did side projects, I would definitely like lean toward the bright end of everything. Could I replace all the colors? Nobody will notice. It'll be fine. Yeah, yeah. Nice. Cool. Oh, well, yeah. Thank you, everyone. That was really fun. Bye, everyone.